Let's talk a little bit more about how ionic compounds form, and we'll do this using Lewis structures. Remember that all an ion is a charged particle. So a cation is a particle that has lost electrons, and this gives it a positive charge. An anion is a particle that has gained electrons and has a negative charge. And as we saw before, cations tend to be metals because metals lose electrons very easily, and anions tend to be nonmetals because they tend to gain electrons. The way that I remember which one is which is that the T in cation kind of looks like a positive or plus sign, so cations are positive, and anions therefore must be negative. Now let's say I have two atoms. So I have a lithium atom, and lithium has one valence electron, and I have a bromine atom, and bromine has 7 valence electrons. Lithium needs to lose 1 valence electron. Bromine needs to gain 1 valence electron in order to have a complete octet. So that's exactly what's going to happen. Bromine's going to take the electron from lithium, and lithium ends up with a positive charge, plus 1 because it lost an electron. Bromine now has all 8 of its valence electrons, its outside electrons, giving it a negative 1 charge. These charges are opposite signs but equal in absolute value. They're both 1s, and they form a neutral compound. Notice how the ionic compound has no charge. If we look at another example, let's say we have calcium. Calcium has 2 valence electrons, and we'll react that with oxygen. So oxygen has 6 valence electrons. Calcium needs to lose 2 electrons. Oxygen needs to gain 2 electrons. So both of these electrons are going to go over to oxygen. And what we end up with is calcium gets a plus 2 charge, as expected from the periodic table. And oxygen gets a minus 2 charge. These charges are opposite in sign but equal in absolute value. So these are going to attract each other and combine into our ionic compound, which is calcium oxide. Now what happens though if my charges are different? I don't have the same number of electrons to give and gain. Let's use barium, which has 2 valence electrons, and fluorine, which has 7 valence electrons, as an example. So we have a metal which wants to lose electrons. We have a nonmetal which wants to gain electrons. So barium is going to give an electron over to fluorine. And if we notice, well, now fluorine has 8 electrons. Its octet is complete. It can't gain any more. But barium still has this other electron that has to be given away for it to become stable. So what's going to happen here is we need another fluorine atom. So we need a second fluorine atom. And the barium's going to give this other electron to that fluorine. So what we end up with is barium with a plus 2 charge because it lost 2 electrons, and then 2 fluorines, which now have complete octets, with -1 charges, because each fluorine gained 1 electron. Gaining 1 electron gives a negative charge. Losing 2 electrons gives a positive 2 charge. Notice again that our signs are opposite but equal in absolute value. Barium's positive, the fluorines are both negative. The total positive charge is 2. The total negative charge is 2. It's balanced. So our final compound is actually BaF2. Now, what does this subscript mean? What does this little number mean in a chemical formula? Well, the little numbers are called subscripts, and subscripts indicate the number of a type of element in a compound. So they indicate the number of a type of element in a compound. So this number 2 here in the F tells us that in the compound BaF2, barium fluoride, there is 1 barium ion and there are 2 fluoride ions. If we look at another example, let's say Ca3P2, this compound contains 2 ions of phosphorus and 3 ions of calcium. So we can have subscripts on all of the elements, and the subscript goes with the element that comes before it. So we have 3 calcium ions and 2 phosphorus ions in that compound. It is also really important to note that ionic compounds have no charge, or ionic compounds are neutral. So even though these ionic compounds are formed from a positive ion and a negative ion, the positive charges and the negative charges must cancel each other out. Another way of saying this is that the positive and negative charges must be equal in absolute value, but opposite in charge. And this is going to come into play next when we start talking about how we determine what the formula is of an ionic compound without actually having to write out the Lewis structures. So if the positive charge on an ion is +2, then the negative charge of the ion in that compound must be -2, or the total negative charge must be -2, because +2 plus -2 equals 0.